Alright, well, hi everyone. Let's go ahead and do this practice test. And these first three are solving absolute value equations. And you remember we isolate, if it's not already isolated, the absolute value. We split, we solve, and we check. Let's remember those on these first three. So number one, isolate. This has already got the absolute value by itself on this side. So now it's time to split. And our y plus 3 equals 17, or y plus 3 equals negative 17. And then we solve both equations. I'm going to subtract 3 from both sides. I got y equals 14. I'll subtract 3 from both sides here, and I get y equals negative 20. So y equals 14, or y equals negative 20. And now I'm going to solve, or that's the solving. I'm going to check in the original equation. Does the absolute value of 14 plus 3 equal 17? Put a question mark. This is the absolute value of 17. Does that equal 17? And yes, it does. That checks out. Let's try negative 20. The absolute value of negative 20 plus 3, is that going to equal 17? That's the absolute value of negative 17 equaling 17. Yes, 17 does equal 17. That checks out. The absolute value of negative 17 is positive 17. So both of those are solutions. All right, number two, isolate. This has got this plus 8, so the absolute value is not isolated yet. So I'm going to subtract 8 from both sides. And then I have the absolute value of 4x minus 3 equals negative 7. Now, I'm going to say the split step. But just remember, when we come back and look at this, actually I'm going to write it over here again. Just remember what we had. Okay. This isn't anything necessary. I'm going to make a point after I finish this. So I take off the bars, and then I go 4x minus 3 equals 7. I add 3 to both sides. I got 4x is equal to negative 4. And I divide by 4. I've got x equals negative 1. I add 3 to both sides here. I have 4x equals 10. I divide by 4, and I get x is equal to 2.5. So now it's time to check. You check in the very original problem. Absolute value of 4 times negative 1 minus 3 plus 8. Is that going to equal 1? Well, this is negative 4 minus 3 is negative 7. Absolute value of negative 7 plus 8. Is that going to equal 1? Absolute value of negative 7 is 7. Does 7 plus 8 equal 1? The answer is no. Negative 1 does not work. Let's try 2.5. Absolute value of 4 times 2.5 minus 3 plus 8. Is that going to equal 1? 4 times 2.5 is 10. So that's 10 minus 3 plus 8. Is that going to equal 1? That's absolute value of 7 plus 8 equaling 1. 7 plus 8 is still not going to equal 1. This does not work. If both of them don't work, we write no solution. So this is not catching it. But if I think about the absolute value of whatever turns out here, if I take the absolute value, no matter what x is, it's going to be 0 or positive. And 0 is never, or whatever it is, 0 or any positive number is never going to equal -7. If you caught that there, you can go straight to the no solution answer. All right. Give myself some room there. Number 3. When the absolute value is isolated, so I'm going to split to 3x minus 1. Notice I take the bars completely off. Equals 2x minus 4. Or 3x minus 1 equals, I'm changing this to -2x and this to +4. I'm changing all the signs for the second equation when I split. I'm going to subtract 2x from both sides on this one, and I have x minus 1 equals -4, and I will add 1 and have x equals -3. This one, I'm going to add 2x to both sides. I have 5x minus 1 equals 4. I will add 1 to both sides. I got 5x equals 5. And I'll divide by 5, and I'll get x equals 1. So I've got x equals -3 or x equals 1. I do need to check. I'm going to check -3 first. The absolute value of 3 times -3 minus 1 equals 2 times -3 minus 4. Let's see. This is -9 minus 1. That's the absolute value of -10. This side, -2, or 2 times -3 is -6. -6 minus 4 is -10. Does the absolute value of -10 equal -10? Well, absolute value of -10 is 10, so no, they are not equal. This one's extraneous. -3 does not work. Let's look at this one. 1. Absolute value of 3 times 1 minus 1. Oops, that's a straight bar there. Does that equal 2 times 1 minus 4? Okay. 3 times 1, that's 2. And 3 times 1 is 3. 3 minus 1 is 2. The absolute value of 2. Is that going to equal 2 minus 4? Absolute value of 2 is 2. That is not equal to, this is -2 over here. So this one doesn't work either. So there's no solution on that one. Alright, just look over my work here real quick. Okay, I think we're good. Neither of them worked. There's just no solution on that one, from as much as I can tell here. Okay. Alright. It's possible that one like this, that you could get one solution. It's just not here. And it's not on this one. Alright, now we are solving inequalities. We're going to give them as simplified inequalities, and we're going to graph our solutions on number lines as well. So we'll go plus 14 to both sides here. No splitting or anything like that. That goes only with the absolute values. So negative 6z is less than negative 18. Negative 32 plus 14 is negative 18. Divide by negative 6. I got z is greater than negative 3. Alright. Let me put 0 here, negative 1, negative 2, negative 3 here. 1, 2, 3 here. That number line's pretty small. z is greater than -3. So I'll put an open circle on -3, and I will go with a heavy arrow greater to the right. Alright, number 5. I'm going to add 4x to both sides first. When I have two variables on each side of the inequality, I'm going to take the opposite of one to both sides first so that I get rid of it on that side. I'm going to add 7 to both sides here. I have 14x greater than or equal to 28. And I divide by 14, and I got x is greater than or equal to 2. So I'll put 2 here, 1 here, 0, -1, 3, 4, 5. X is greater than or equal to 2. So I'm going to put a closed circle and heavy arrow to the right again. Okay, that was 5. Number 6. Now this is an OR problem. I'm going to work each one separately. So I'm going to add 6 to both sides on this one. And I got g is greater than or equal to -5. I'm going to subtract 4 from both sides here. And I have 2g is less than -19. I'll divide by 2, and I got g is less than -9.5. G is greater than or equal to -5, or G is less than -9.5. Alright, so I'm going to go -10 here, -8, -6. I'm going to skip. Just put even ones down here for right now. -2, 0, 2, and so on. Alright, G is greater than or equal to -5. Well, -5 is right here. And it's an OR, so I'm going that way with it. Alright, -10's here, -9's here. Halfway between is -9.5 right here. And I'm going to go heavy arrow on this side. I've shaded all the acceptable values for G. Everything that you could plug in that would make either this one true or this one true. This is an AND problem. 4x plus 8 is less than or equal to 32, and 4x plus 8 is greater than or equal to 12. I like to start in the middle. We'll get an x by itself. Subtract 8 from the middle, from the right, and from the left. I got -20 here, less than or equal to 4x, less than or equal to 24. 32 minus 8 is 24. Now let's divide 4 in the middle, 4 on the right, and 4 on the left. I got -5 is less than or equal to x, which is less than or equal to 6. Alright, I'm going to put -6, -4, -2. I'm just plotting the even ones right now. 2, 4, 6, 8. Okay, this is AND. -5 is right here. 6 is right here. Shade between the two. And there's an AND. See the OR and the AND. Okay. And that's important on 8 and 9. This is great OR. Okay. So, great OR, I'm going to write 4x minus 7. I'm going to split now. Is greater than 13. Or 4x minus 7 is less than -13. I'm going to add 7 to both sides here and have 4x is greater than 20. I'll divide by 4 and I'll have x is greater than 5. I'm going to add 7 here and here. I got 4x is less than negative 6. And I'll divide by 4. And x is less than negative 1.5. Negative 4, negative 2, 0, 2, 4, 6. Okay. Now, x is greater than 5. 5 is right here. Open circle on 5, or, it's a heavy arrow to the right. X is less than negative 1.5. Well, here's negative 1, here's negative 2. I'm going to put an open circle right between negative 1 and negative 2. And heavy arrow to the left. Alright. Next, absolute value of 5z plus 2 is less than or equal to 17. Remember this? Less than. Alright, I like to do this with the ands. Put it between negative 17 and 17. Just leave this the same. This will point the same direction, but it's on the left side of 5z plus 2. I'm going to subtract 2 from both the middle, the right, and the left. That's negative 19, less than or equal to 5z, less than or equal to 15. I'm going to divide by 5, in the middle, right, and left. I got z is less than or equal to 3, greater than or equal to negative 3.8, I think. Yeah. Okay, you can check that on the calculator. I'm going to go negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. As I label, z is greater than or equal to negative 3.8, right close to negative 4 here, not quite negative 4, and less than or equal to 3, right on 3, heavy or shaded between the two. That's where the solutions are to this. Alright, last one. Define a variable and write an inequality for each problem, then solve. The difference of 3 times a number and 16. Okay, n equals my number, or our number, or a number, the number. The difference of 3 times a number, difference is subtraction, right? And 16. So I'm going to write 3n minus 16. The difference of 3 times a number and 16. 16 is being subtracted from. Is at least. Okay, at least means the least it can be is 8, which means this has got to be greater than or equal to. That gets a little confusing, but that's greater than or equal to 8. Now I will add 16 to both sides. I got 3n is greater than or equal to 24. I'll divide by 3. N is greater than or equal to 8. Alright, there's your practice test.